Okay, folks, so continuing our work with square roots. Yesterday, we talked about how to multiply square roots. And I want to remind you that when we multiply square roots, we begin with the multiplication, and we multiply the outside number times the outside number, as well as the inside number by the inside number. And remember that that will produce one square root. And then we simplify that answer. So we did problems like this. I could ask you to multiply 2 square roots of 10 times 3 square roots of 5. So we'll begin with the multiplying. We'll do the outside times the outside. 2 times 3 is 6. Then we'll do the inside times the inside. 10 times 5 is 50. And so that produces this square root, 6 square roots of 50.
136, 58, 136, 58.
Okay, so now we will simplify this answer. So remember to simplify that square root of 50. That what we want to do is break it down into 2 square roots that will multiply to give us 50. And when we break it down into these 2 square roots, we need to make sure that one of our numbers is in that perfect squares list. So if you'll go to your list, find the biggest number in that list that will go into 50. That is 25. And we know that it takes 25 times 2 to give us 50. So this is going to become 6 times the square root of 25 times the square root of 2. We break down our square root into 2 square roots. One of those numbers that we use has to be a perfect square. All right, so now to finish this off, we know that the square root of 25 is 5. So we can do that to simplify. And then, of course, we can multiply 6 times 5 and get 30. So 30 square roots of 2 would be our final answer. So outside times outside, inside times inside, and then we simplify that final answer. Now, today what we're going to do is we are going to add and subtract square roots.
91 plus 91.
So you all can see I didn't pick a real good time to make my video. I want a mute button for that intercom. All right, so add and subtract square roots. That's the next thing that we want to work on here. Now, adding and subtracting square roots is going to be different from multiplying because in order to add and subtract, and this is true always, you must have like terms. You must have like terms in order to add and subtract. So if you don't have like terms, then it's not possible to do that. Now, to kind of remind you what like terms are, you know, early on in algebra, you all have done things like 2x plus 3x. Those are like terms because they both end with x. And you all know that if you add 2x plus 3x, you get, 5x. If I were to ask you to add 2x plus 3y, those are not like terms because this one ends with x and this one ends with y. So I would not be able to add those together. So 2x plus 3y would be my answer. So like terms can be added and subtracted, unlike terms cannot. Now how's that going to look with square roots? Well, if I were to ask you to do 2 square roots of 3 plus 4 square roots of 3, those are like terms. And those are like terms because both of them have the square root of 3 attached to them. So if I wanted to add those together, I could. I would add 2 plus 4 and get 6, but I wouldn't change the ending. If you have 2 square roots of 3 plus 4 more square roots of 3, then you have a total of 6 square roots of 3. Just like over here, when you have 2 x's plus 3 more x's, you have a total of 5 x's. Notice that we don't change that ending. So 2 square roots of 3 plus 4 more square roots of 3 would be 6 square roots of 3. If I were to try to do a problem like 2 square roots of 3 plus 3 square roots of 4,
134 plus 134.
2 square roots of 3 plus 3 square roots of 4, these are not like terms.
Plus 81 plus 81.
These are not like terms because we have the square root of 3 in one of them and the square root of 4 in the other one. So on this one, we wouldn't be able to add those together. So this is the thing that's going to make adding and subtracting different. You're going to have like terms. Now, to add and subtract square roots, here's what we are going to do. The first thing you are going to do is simplify each radical. And I'll show you why in just a minute. But you're going to simplify each square root in the problem. So notice that's different because on multiplying, we simplified at the end. On adding and subtracting, we're going to simplify at the beginning. And then you are going to combine the like terms. So simplify each square root and then combine like terms. All right, so let's look at some examples. All right, on this first one, we are going to do this problem. 5 square roots of 3 plus 2 square roots of 5 minus 8 square roots of 3 plus 9 square roots of 5. So notice 2 of these have the square root of 3 and 2 have the square root of 5. So the first thing I'll do is check to see if I can simplify. So could I take the square root of 3 and break it down into 2 square roots so that I could simplify it? Well, you can see that we can't because the only way to get 3 is 1 times 3. The square root of 1 is 1, so it's 1 times the square root of 3, which is just the square root of 3. That's not going to simplify. Same thing happens when I try to simplify the square root of 5. When I break it down, it becomes the square root of 1 times the square root of 5. Square root of 1 is just 1, and 1 times the square root of 5 is just the square root of 5. So none of these radicals up here can be simplified. So now what I'll do is I'll go through and combine the like terms. Well, I have 5 square roots of 3 minus 8 square roots of 3. Those are alike because both have the square root of 3. 5 minus 8 is negative 3 square roots of 3. So notice I combine those outside numbers. 5 minus 8 is negative 3, but I don't change the ending. Now I can also do positive 2 square roots of 5 plus 9 square roots of 5. 2 plus 9 is 11, so I have plus 11. square roots of 5. And that would be my final answer. That's as far as I can go. So go through and try to simplify the radicals. In this case, they won't. And then combine the like terms. All right, now let's look at an example where you do have to simplify. All right, so on this next problem, we're going to do the square root of 27 plus the square root of 48. Now you'll notice that right now these are not like terms. One of them is the square root of 27, the other is the square root of 48. So I'm going to simplify first. So let me start with the square root of 27. To simplify that, I try to split it into 2 square roots. So I need numbers that will multiply to give me 27, and I want one of those to be a perfect square. 27 we know is divisible by 9, so we can make that the square root of 9 times the square root of 3. Now I'll go over here to the square root of 48 and do the same thing. I want to split him into 2 square roots. So I need 2 numbers that will multiply to give me 48. One of those needs to be a perfect square. So if I go through the list, I'll find that 48 is divisible by 16, and it is 16 times 3. All right, simplifying this a little further, the square root of 9 we know is 3, so that becomes 3 square roots of 3, plus the square root of 16 is 4, so this becomes 4 square roots of 3. And now notice that after simplifying, I do have like terms, so I can add these together now. So 3 square roots of 3 plus 4 square roots of 3 will give me a total of 7 square roots of 3. So this is why that simplifying step is important. These 2 square roots at the beginning did not look like terms, but after simplifying them, you can see that they were. So when we add and subtract, you're going to do your simplifying first, and then add your like terms together. All right, let's do this time 3 square roots of 27 minus 2 square roots of 12. So notice, right now this is a subtraction problem that I'm not able to do because these two are not like terms. So I'm going to try to simplify 3 square roots of 27. So I'll hang on to my 3, and I'll break the square root of 27 down into a multiplication problem. So I need numbers that'll multiply to give me 27, and I need one of them to be a perfect square. So 9 times 3 is what I should use there. And then I'll do the same thing over here. Keep my 2. And then I need 2 numbers that will multiply to give me 12, where one of them is a perfect square. So that would be 4 times 3. All right, so now simplifying a little more right here. I know the square root of 9 is 3. So this becomes 3 times the square root of 3. And then over here, I know the square root of 4 is 2. So that'll be 2 times the square root of 3. Multiply these two 3's together. 3 times 3 makes that 9 square roots of 3 minus 2 times 2, 4 square roots of 3. And now notice again how I have a subtraction problem that I can do, because these two are like terms. 9 square roots of 3 minus 4 square roots of 3 will leave me with 5 square roots of 3 for my final answer. So do your simplifying first and then combine any like terms that you see. All right, one last one. All right, we're going to do 8 square roots of 50 plus the square root of 45 minus 2 square roots of 72 plus 3 square roots of 20. So notice I have 4 square roots. None of them are the same. So right now I can't add and subtract anything. So I'm going to simplify first to see if any of them turn out to be the same. So we'll start by simplifying 8 square roots of 50. Keep your 8. And now you need two numbers that will multiply to give you 50, where 1 is a perfect square. So 25 times 2 would be the way to go. For the square root of 45, I need two numbers that will multiply to give me 45, where 1 is a perfect square. So we're going to do 9 times 5. On the next one, two numbers to multiply to get me 72, where 1 is a perfect square. That will be 36 times 2. And then finally, square root of 20, two numbers to multiply to give me 20, where 1 is a perfect square. That's going to be 4 times 5. All right, so going through to simplify. I know the square root of 25 is 5. So this is going to be 8 times 5 times the square root of 2. Plus, I know the square root of 9 is 3. So that's going to be 3 square roots of 5. Square root of 36 is 6, so that's going to be 2 times 6 times the square root of 2. Square root of 4 is 2, so that's going to be 3 times 2 times the square root of 5. All right, almost there. Let's go ahead and finish this up. 8 times 5 gives me 40 square roots of 2 plus 3 square roots of 5 minus 2 times 6, that'll make that 12 square roots of 2 plus 3 times 2 will make that 6 square roots of 5. All right, so now we can see that once the simplifying is done, that some of the radicals are alike, some of the square roots are alike, so let's combine like terms. We're going to do 40 square roots of 2 minus 12 square roots of 2. 40 minus 12 would give us 28 square roots of 2. And then we can also do 3 square roots of 5 plus 6 square roots of 5, which is 9 square roots of 5. And that's as much as that answer can be simplified because these two aren't like terms. So adding and subtracting is going to be a little different than our multiplying was. On multiplying, we could just dive right in and do the outside times the outside and the inside times the inside, and then simplify at the end. When we add and subtract, you're going to have to simplify each of the square roots first. And the purpose of that is so you can see which ones are like terms, because then to add and subtract, you're going to combine the like terms. They have to be alike or you cannot add and subtract. Give today's problems a try. If you have questions, please let me know.